everyone, welcome to JEE Advanced Aspire. My name is Shimon Joseph and I am your maths master teacher at Vedantu. So guys, today we'll be discussing a good number of questions on the topic complex numbers. I'm sure all of you have been following this Aspire series for almost the last 2 weeks. There are lots of good questions being discussed. Please try to make a note of it and learn them. They'll be super beneficial for you in your JEE Advanced. Okay guys, so let us get started. But before we get into the questions, let me just inform what is Aspire to all the newcomers over here. So JEE Advanced Aspire series Maths is taken by Pulkit sir, myself and Arvind Sudhar sir. So we'll be splitting topics between us and bringing to you a lot of interesting questions. Do take part and learn so that you can rock it in JEE Advanced guys. Okay. And what is the program for Aspire? You have 5-week program which started on April 15th. You can find those videos in the Vedantu channel. And every day you have one subject. So today it's maths. So tomorrow you might have physics. And the day after you'll have chemistry. And it goes in that cycle. Only Thursdays we'll take an off. Okay guys? So that is the schedule for Advanced Aspire series. But towards the end, when you guys are a bit free after giving all these exams, BITSAT, VIT and all the other engineering exams, we would conduct the last mile bolt, which will be super intensive because you have 3 classes a day towards the end of our preparation. Okay guys, so with that, let us get started with our discussion today on complex number. The first question over here. So last time people had requested me to move away from the screen, so I hope it's visible now. So here we have a question which says ABC is a triangle inscribed in a circle. I'm sure all of you are aware mod of z equal to r is a circle, okay, because mod of z is nothing but distance. So distance from our point O, which is nothing but the origin, is going to be fixed because r is a constant here. So when my fixed distance is there between 2 points, I know my z is going to trace a circle. As simple as that. Now the internal angle bisector of A. So you have a triangle ABC, you have an internal angle bisector and the altitude are drawn to meet the circle at D and E. Okay. And F is the foot of perpendicular from A on BC. Now if Z1, Z2 and Z3 are nothing but A, B and C, I want you to find out what is D? That is the first question. But guys, this is a comprehension. We have 3 more questions coming up under the same question. Okay. So I want all of you to try it out. I hope the question is clear and it is visible to everyone. You can pause the video now. Try it out. It's one of the best questions you can come across in complex numbers. Lots of learning points to be taken away from here. Okay. And that is why we are going to discuss this first. I know it will take some time to discuss this, but still it is totally worth it guys. So let us get on with it. Now, for those who want to try, pause the video. I'm going to move to the solution part of it. So when I come to the solution, I would like to first give you the diagram so that a few others can also start trying to solve this question. So how does the diagram look like? Let us have a look at it. So you have a circle. Okay. So you have a circle and the center of the circle is what? Center of the circle is origin. And why is the center of the circle origin? Because it is mod of z minus 0. So distance of z measured from origin is going to be constant. So that is my circle over here and I hope that is clear. Now after I know that, I have a triangle inscribed in this circle. So I have a triangle ABC. Let us say it is like this. You have A, you have B and you have C. Okay guys, is that clear? Very simple. I drew a triangle inside a circle. Now can I call this circle as the circumcircle of ABC? Can I call this circle to be the circumcircle of triangle ABC? Absolutely yes. I can say that because what is the definition of circumcircle? It passes through all the 3 vertices. Okay. So since it passes through all the 3 vertices, I can say that this is my circumcenter. Let us name it using a different character because C is already used. So let us say O. Okay. So O is my circumcenter and OA, OB, OC are all equal because they are nothing but the radius. Now moving on to the second piece of information. The internal bisector of angle A and the altitude from A on BC. There are 2 things being drawn. Read it very carefully. You have internal angle bisector being drawn, and then you have the altitude from A also being drawn towards the side BC. So let us draw both of them. So let me say this is my angle bisector AD, and let us say this is my perpendicular, that is altitude, and they meet the circle at D and E. So guys, please read it carefully. They meet the circle at D and E. Okay, so now that is what I did. That is exactly what I did. Now moving on, F is the foot of perpendicular from A on BC. Now how do I interpret that? Can you guys guess which is the point F? Any idea? So the point F is nothing but this point over here, which is nothing but the foot of perpendicular when dropped from A on BC. Is that clear? That's it, done. Now my diagram is ready. I should get solving. Perfect. So let me write down the other information, which is Z1 is nothing but my point A, Z2 is my point B, and Z3 is my point C. So guys, we are all set. Start solving. Pause the video, try it out, struggle for a while, and then come back so that you can appreciate the solution. Okay, good. I hope all of you will try it out and then come back to the video. That is a request from my end. Okay, so let us start solving this question. So here, definitely this question is based on the concept of rotation. And why do I need rotation? Let us have a look at it. Okay guys, so now the first question is what? Find the point D. I need to find out what is the complex number representing my D. Got it? So for that, what I'll do is, watch carefully, I will join O to D and O to C. Okay, so guys, what is this angle? This angle is A by 2, because AD is the angle bisector. If AD is the angle bisector, then AD will bisect the angle of A. So this will be A by 2. Now look at the chord CD. Now CD is a chord of the circle, right? Because CD is a line joining 2 points on the circle. So if I treat CD like a chord, I know that angle subtended at the circumference is half of the angle subtended at the center. So the angle subtended by CD at the center will be what? A. That is a good point, right? So the angle subtended by CD at the center will be twice of the angle subtended by CD at the circumference. At the circumference it was A by 2. So twice of A by 2 will be A. And that is exactly what I have drawn. Is it right? Perfect. So now I will start with rotation. And guys, I know some of you may not be knowing rotation. I will tell you a simple rule which, if you keep in mind, you can crack any question of rotation. So let us try to pay attention carefully. Okay. So now what I will do is, I will mark this angle A in the anti-clockwise direction. So guys, is this anti-clockwise? Look at it, the way I have drawn the arrow. Is it anti-clockwise? Yes, because it is going opposite to the way a clock moves, right? So that is why it is called anti-clockwise. Now I write it in anti-clockwise, and wherever the arrow points, I will write that complex number first. So wherever the arrow points, what is that line? That line is OC. Okay, so OC is nothing but Z3 minus 0. Because OC is nothing but what? Z3 minus 0. That is the representation of OC as a vector form. You can think of it like that. Now, what is the bottom? We saw one side of the arrow point. What is the other side of the arrow point? Where does it start from? It starts from OD, right? So what is OD? D is what I want to find. So I will have D as Z. Let D be something, some Z which I want to find out. Okay, so it is going to be Z minus 0. So that is how rotation starts. On the right hand side you write that. That will be equal to modulus of Z3 minus 0 by modulus of Z minus 0 into e to the power I angle included between them. That is A. That is the form of rotation. Okay guys, is that clear? So how do you write rotation? Rotation is nothing but when you have anti-clockwise direction angle, wherever the arrow points to, I will write that vector first, divided by the one at the bottom, which is OD, and that will be equal to the ratio of the modulus. the ratio of the distances into e to the power I a. And why do I write it as e to the power IA? Because I follow this anti-clockwise rule. If you go the other way, then if you go clockwise, then what will I do? I will write it as e to the power minus IA. Is that clear? So those differences you have to be very clear of, guys. Perfect. And if you really want to go in depth about rotation and learn it from the basics, then I would recommend you to take some standard textbook, go through it, and then come and have a look at this lecture. Okay, so that is how rotation is used. I hope it is clear. Again, I'll repeat it one last time. So when you want to use rotation, you draw the angle first about which you are going to rotate. You have a pivot point, right? So here, what is my pivot point? My pivot point is O, because O is a fixed point. Now I want to rotate this vector about O. So what do? I mark the angle first. So when I mark the angle, I mark it in an anti-clockwise direction, because that is going to save me a lot of time. I can directly write it in this form. So when I write it in anti-clockwise direction, I write wherever the arrow points to that vector first, which is nothing but OC, and OC is nothing but Z3 minus 0. And similarly, OD is the second vector which I divide by. That is going to be Z minus 0. Is that clear? That will be equal to modulus of both of them, the ratio, into e raised to the power IA. Now, what is the ratio of the modulus? Can anyone tell me? Any idea about the ratio of modulus? So here you have OC and OD both being radius, guys. So if both are the radius, what is the ratio? This will get cancelled out. That's it, as simple as that. Now I have one relation. Do I get the answer now? Absolutely not. Because I still don't know A, right? A is not known to me. I just named it as A and then I solved it. But is A given to me in the question? Not at all. I have to find out what is A. But is that needed? Think about it. I can do something else. And what is that something else? I can do the same thing with respect to BD. So when I do the same thing with respect to BD, what do I get? So guys, don't you think BD is also a chord of the circle? So don't you think BD is also a chord of the circle? If BD is a chord of the circle and it subtends an angle of A by 2 at the circumference, I hope you get it. This point, this angle is also A by 2. And why is that angle A by 2? Because AD is the angle bisector. So if AD is the angle bisector, this angle will be equal to A by 2. And if BD is subtending A by 2 at the circumference, then at the center wall, what will it subtend? It will subtend an angle of A. That's it. So BD chord will also subtend angle A at the center. That is a useful information and I will use that to get my answer. Again, I will mark A in the anti-clockwise direction. So can you guys write down the expression for BOD? The rotation of BO and OD. Can you guys write the expression and check whether you have understood this? I will give you 1 minute. Please try to do that and compare yourself with what I write on board here. Okay, so let me do the writing for the rotation BOOD. So now what do we get? Wherever the arrow points, I will write that vector first. Now the arrow points to OD vector. So OD will be written first. And what is OD? OD is nothing but Z minus 0 divided by OB. Now I want to understand what is OB. OB is very simple again because I know B, that is given to me in the question, and I know O as well. O is nothing but the circumcenter, which is nothing but the origin here. Okay, so it will be by Z2 minus 0 is equal to mod of Z minus 0 by mod of Z2 minus 0. This is a format for rotation that comes from basics, which I am not discussing over here. I hope you guys know that. If not, please refer a standard textbook, guys. Okay, and that will be equal to e to the power IA again. Directly e to the power IA again because I followed anti-clockwise order. Okay, I followed the anti-clockwise order. Now I have beautiful relations. I have one relation here, one relation over there. And guys, don't you think these two will cancel out? Because again, OD and OB both are my radius of the circle, and therefore both of them will get cancelled out and I end up with such a simple expression. Can I get Z now? Yes, absolutely, because I can get rid of A. Because here also I have e to the power IA and here also I have e to the power IA. So can I compare the quantities on the left hand side? Absolutely yes. So let me write that down. What do I have here? Z3 by Z is equal to Z by Z2. So what do I have? Z2, Z3 is equal to Z square. So Z is equal to square root of Z2, Z3. Easy? Good question. So I hope all of you liked it, and guys, if you have any doubts, please do leave me a comment in the chat box. I will help you out. I will be there with you guys. Okay. So let us have a look at it again quickly. So what I did here is I used the concept of rotation. I used some of the properties of circles. What are the properties of circles that I used here? I know that a chord of the circle, if it subtends an angle at the center, then the angle subtended at the circumference will be half of the center. Got it? So that is a property which I frequently used here. So it is A by 2 here, so center will be A. Similarly for BD chord, A by 2 here, so at the center will be A. Is that clear? So after I found out the angles, I used the concept of rotation of complex numbers. Very good question. If you have doubts, let me know. We will discuss it further. And how did I get the answer? E to the power IA was common on the right hand side of both these equations. So I took the left hand side and compared them. So when I compare them, I get Z square is equal to Z2, Z3, and that leaves me with Z being equal to square root of Z2, Z3. Okay, so that is how it is done. Let us go back and see if you got the right answer. So let us go back to the question. So the question is over here, do we have a square root of Z2, Z3 in the option? Do we have a square root of Z2, Z3 in the option? Yes, absolutely. So let us mark that. That will be our answer for this question. Okay. So B is the correct answer for this question. I hope all of you got it. So let us quickly move on because we have a lot to cover today. And I want you guys to work with me. Now, the second question is, what is the point E? Okay, you found out D. That is fine. Now, I want you to tell me what is the point E represented by. I want to know what complex number is going to give me E. Okay, I hope the question is clear. Those who want to try, you guys can try it because I have given you some information now. I would always prefer you guys to solve it on your own. Now, let us go back to the solution. So, let me start off again. So, what do we have here? We have a circle and we have a triangle ABC. This question is a bit simple. I'll tell you why. So here we have ABC and the foot of perpendicular is F and E is the place where this altitude meets the circle. So AF is the altitude. I hope all of you understand what is meant by altitude. Altitudes are always dropped from vertex onto the opposite side and they are perpendicular. Got it? And that when extended meets the circle at E. Now I want to know what is E. So let us say the same thing. I will take E to be Z because E is what I want to find out and A is nothing but Z1, B is nothing but Z2 and C is nothing but Z3. So this is pretty simple. We can solve it straightforward. How is it solvable straightforward? Let us have a look at it. So guys, I will ask you one question. Can you guys say that what is argument of Z1 minus Z divided by Z2 minus Z3? Can you guys tell me what is the argument of this? So let me first explain to you what I wrote there. Some of you may not be able to get it because you wouldn't have revised argument and the properties of argument. Let me recap it for you so that all of you are on the same page. Okay guys. So now, what is argument of Z1 minus Z? So by now you should be aware of the fact Z1 minus Z means it is nothing but the line AE. So Z1 minus Z is nothing but the line AE. And what is Z2 minus Z3? It is nothing but the direction of the line BC. So think of it like vectors. So Z1 minus Z is nothing but this vector and BC is nothing but Z2 minus Z3 vector. So if I ask argument of this by this, what do I mean by that? Argument follows the same properties as that of log. So I can say this is nothing but argument of this minus argument of this. So if I do argument of this, that is nothing but the angle subtended by the line joining these two with the positive direction of x-axis, subtract the argument of BC. So when I do that, don't you think I get the angle between them? And guys, what is the angle between these two vectors? The angle between these two lines is nothing but plus or minus pi by 2. It can be plus pi by 2 or minus pi by 2. So let me write it like that. So it is, let's say it is either plus pi by 2 or minus pi by 2. I am not bothered about it because I am going to use some information which I get from this one. Okay, I hope all of you got it. I will repeat it to you again. So AE is nothing but the direction of Z1 minus Z, and BC is nothing but Z2 minus Z3. Now when I say argument of this by this, I am asking you basically the angle between them. So the angle between these two directions I want to know, and as all of you can see over here, the angle between them is nothing but 90. And guys, whenever the argument of some complex number, now forget about everything, if argument of some complex number is pi by 2, don't you think it is purely imaginary? Is it not? So whenever I say argument of some complex number is equal to plus or minus pi by 2, definitely it has to be purely imaginary, guys, because plus or minus pi by 2 lies on imaginary axis. Is that clear? That's it. So that is a huge point, right? So I know my complex number here is purely imaginary. So if this complex number inside is purely imaginary, what can I say? I can say that Z is equal to minus Z bar, because whenever a complex number Z is purely imaginary, Z plus Z bar is 0. I am sure all of you remember that. So a complex number is purely imaginary when Z plus Z bar is equal to 0. So let me write that down. So here what I mean by Z is the entire one. Okay. Please don't think it is just Z. I just wrote it as a short form. Okay. So let me use that result over here to solve it. So what do I have? Z is equal to minus Z bar. That's it. I'll erase everything so that I'll have some space to solve. Okay, so guys, I hope all of you got it. Now, how do I solve this? Because look at the options. I'm sure all of you saw the options. If not, please go back and see the options. Now I can't erase this. If you look at the options, none of the options have bar. None of the options have bar. So I'm a bit confused. Am I going in the right direction? Because the options doesn't seem to be so. But wait a minute, guys. You can get rid of this modulus, right? Get rid of this conjugate by using modulus, because don't you agree Z, Z1, Z2, Z3, all four of them lie on the circle? Because Z1, Z2, Z3 definitely they lie on the circle because they are nothing but the vertices of the triangle whose circumcircle is given. So definitely Z1, Z2, Z3 lie on the circle. So I can say that mod Z1 equal to mod Z2 equal to mod Z3 equal to R, which is nothing but radius of this circumcircle. But what about Z? What is Z? What are we finding? We are finding E, right? So E is the point Z, and does E lie on the circle? Yes, absolutely, because AF, the altitude, is produced to meet the circle at E. Therefore, E is also a point on the circle. Therefore, I can say it is equal to mod Z as well. That is a huge information, because what I'll do here is, listen carefully, I have minus, I have root of, I have conjugate of Z1. Okay, so I have Z1 bar, I will divide by R square. I have Z bar, I will divide by R square. And what do I have in the denominator? Z2 bar, I will divide by R square. Minus Z3 bar, I will divide by R square. Okay? Can you guys see where I am going? Any idea? So now what is R square? First, let me make this clear. I just took this right hand side with the minus. I wrote the minus right hand side. I divided numerator and denominator by R square. And R square is a number, right? I can do that. I can divide numerator and denominator. Is that clear? I divided my numerator and denominator by r square without affecting my left hand side. Is that clear to everyone? Brilliant, guys. So now I will remove r square and write it as, can I write r square here as z1? I'm sorry, z1 bar. Okay. R square is nothing but mod z1 square, and mod z1 square, we know that it is z1 bar. Similarly, here r square, I will write it as zz bar, and the r square in the denominator, I will write it as z2 bar. I will write this as z3 bar. So now I got rid of the bars. Is that clear? Good. It's a huge step, guys, that reduces the difficulty of the question by a large margin. Okay. So now let us solve it. So you have minus, and I will take LCM over here. So you have 1 by z1 minus 1 by z. So it will become z minus z1 by zz1. And denominator, what do you have? 1 by z2 minus 1 by z3, which will be z3 minus z2 divided by z2 z3. Okay. Perfect. So now what will I do? Compare this. I have z1 minus z minus z1. z2 minus z3. I have z3 minus z2. So can I cancel these two? Yes, because that is my left hand side, right? I just worked with my right hand side. Now I am cancelling this and my left hand side. So what am I left out with? Can you guys help me out here? So what is left out? I have 1 equal to minus z2 z3 divided by z1. And what do I want? I want z, right? So take z around this side. So yeah, z is equal to minus z2 z3 by z1. That will be the answer for this question. Good. So guys, let me recap it. But before that, please have a look at it, and if you have any doubt, do comment it down in the chat. I will help you out. Okay. So let us quickly refresh what we did here. So first, I started off with two directions being perpendicular. If two directions are perpendicular, then I can say that argument of first direction by second direction will be equal to plus or minus pi by 2. Now, whenever argument of a complex number is plus or minus pi by 2, I know it is purely imaginary because it lies on the imaginary axis. And because it is purely imaginary, I can say that z plus z bar equal to 0, which gives me z is equal to minus z bar. And that is exactly what I wrote here. Z is equal to minus of z bar. And how do I get z bar? Just apply bar to each and every complex number inside. Okay guys, because you have simple operations, right? Bar is distributive over division as well. So it will be supplied to the numerator as well as the denominator, and in addition subtraction it distributes to each and every element. I am sure all of you are aware of that, right? So that is what I did. Then I wanted to know whether I am going in the right direction. So I had a look at the options and I figured out none of the options have bar in them. But here I have 4 elements with bar on them. So I need to get rid of the bar. So that made me think, okay, I need to get rid of bar. What can I do? What extra information I have for these 4 elements or these 4 complex numbers? I know that all 4 of them lie on the circle z mod z equal to r. Okay, so now I can say that mod z1 is equal to mod z2 is equal to mod z3 equal to r. That is known because obviously the triangle is inscribed in the circle. But the other one, mod z, which is e, also lies on the circle, and I can say that also. And using that, I divide numerator and denominator by r square. And wherever r square comes, I write it correspondingly. So when I divide z1 bar by r square, there I write r square as mod z1 square. So mod z1 square can be written as z1 bar. That's what I did. Now when I come to z, I write r square as mod z square, so that I can write it as zz bar and cancel out z bar and z bar. Likewise, I cancel out the denominator as well. And after that it is simple calculation. I hope all of you got it. Brilliant question guys. Okay. Okay, good. So let us move forward after we mark the answer. Let us go back and see if we got the correct one. So here, which is the correct one, guys? We have option C, right? Option C is nothing but minus Z2 Z3 by Z1. So that is how you solve it. That will be the answer for our question. So quickly, let us move forward. We have two more questions inside this comprehension, and I have brought some extra questions as well. Let us discuss them quickly. Okay, so the next question is orthocenter. So this is pretty simple. This can be done even if you didn't do the first two. I will show you how. Okay, so even if you did not get the first two ones, this should have been done. So guys, this is a simple observation for your advance as well. So whenever you find a comprehension, just because you can't do the first question, please don't leave the entire comprehension. Just read through it completely so that at least a partial one can be got instead of leaving everything. And this represents that. Okay, so let us have a look at it. So here you have the orthocenter. Now let us draw the circle and see what is happening over here. So you have a triangle ABC, and these are nothing but Z1, Z2, Z3, and the circumcenter is known. Guys, is the circumcenter known? Circumcenter is of course known because circumcenter is nothing but this circle. So what is my circumcenter? Circumcenter is origin. Okay, so circumcenter is known. Is my centroid known? Can you guys tell me whether centroid is known or not? Guys, centroid is definitely known because just like coordinate geometry, what is the centroid of a triangle? x1 plus x2 plus x3 by 3, comma y1 plus y2 plus y3 by 3. That is in coordinate geometry. In complex numbers, centroid is nothing but z1 plus z2 plus z3 by 3. That's it. Over. So I know my centroid because Z1, Z2, Z3 are given to me. And do the answers contain Z1, Z2, Z3? They contain only Z1, Z2, Z3. So I am going in the right direction. I am happy. But now I will be using a super property which all of you are aware because we have been discussing it for so long, and it is super useful in JEE Mains as well. And what is that? The centroid divides the line joining orthocenter and circumcenter in the ratio 2:1. Is that clear? So that property will be used here, and the way you remember this property, some of you may be knowing if you attended my class previously. So the way I remember it is, so if you remember this company ONGC, how many of you know that? Oil and Natural Gas Corporation of India. Yep, so ONGC is an oil company and many of you may be aware of it. So let us say ON is my orthocenter and G is my centroid and C is my circumcenter. So remember this has two letters, so you have 2 and this is one letter, so it is 1. Okay, so centroid divides the line joining orthocenter and circumcenter in the ratio 2:1. Pretty simple, just to keep it in mind. Okay, I hope that is clear. Now let us start solving this. So guys, the way section formula is applied in complex numbers is a bit different. Okay, so here you don't have x coordinate, y coordinate, right? It is just directly complex numbers. So if I say my orthocenter is Z and I know my centroid, I know my circumcenter. So what is centroid? Centroid is Z1 plus Z2 plus Z3 by 3. That is equal to what? Twice ZC. That is twice of what? Twice of the circumcenter. So it is going to be 2 into 0 plus 1 time orthocenter. What is orthocenter? I don't know. I will write it as Z. Divided by 2 plus 1. So divided by, okay, what did I do? Okay, yeah. So divided by 2 plus 1. So now can I cancel this 2 plus 1 and 3? And 2 into 0 is 0. So what is my orthocenter? My orthocenter is nothing but Z1 plus Z2 plus Z3. That's it, over. Got it? So please go through it. I have written everything over here. If you have doubts, let me know in the chat. Okay. So there are two information. First I figure out the centroid, and how do I figure out the centroid? Again by using section formula, and we already know the formula for complex numbers, which is nothing but Z1 plus Z2 plus Z3 divided by 3, where Z1, Z2, Z3 are the vertices of my triangle. Okay guys, so that is exactly what I did. Now that is not enough, right? I want to find out my orthocenter. And how do I find out orthocenter? For that, I go back to my ONGC rule. And what is ONGC rule? It says that the centroid divides the line joining my orthocenter and circumcenter in the ratio 2:1, and that property is useful for me to arrive at the answer. Okay? I hope it's clear. So the answer is going to be option B. Is it not? So let us move forward. I hope all of you have got it. If you have queries, please do post them. We will discuss it further. Now, the best part of this question. This is the best part. Okay guys, so here I'm going to teach you something, a little bit of geometry. I hope all of you are ready, and please pay attention carefully guys. Okay. So first let me state the rule and then I will derive it for you. Okay. So here they are asking you to find the point F. Now let us come back to see what is the point F. Point F is nothing but the place where my altitude meets the side BC. Is it not? So point F is not that simple to calculate because of one reason, it is not on the circle. So previously whatever we found out, D, E and so on, all of them lied on the circle. So somehow I can relate some chord, bring in some properties of circles, try to solve it. It is done. But now you have a point on the triangle. It lies on BC. So let me draw that for you quickly. Yeah. So you have, this is the third time I'm drawing this. Yeah. Okay, so you have A, B and C. You are supposed to find this point F. Okay, and this is E. I hope you guys remember that. Now guys, let me derive a superb result for you which you can take and use it for any triangle. Okay, so before that let me use some geometry here. So what I'm going to do is I'm going to draw another perpendicular from B onto AC. And let me call that, let's say, D. Okay. Is that fine? Everyone okay with that? So I'm just dropping a perpendicular from B onto AC, which is meeting at the point D. Okay. So now, what is the point of intersection? This is nothing but orthocenter. Is that okay? So orthocenter is usually given by H or O. You can use them interchangeably, and because I used O for circumcenter, I will say H is my orthocenter. Okay. So guys, now H is my orthocenter. Why is H my orthocenter? Because it is the point of intersection of altitudes, and AE is one altitude, BD is one altitude, and where are the altitudes meeting? They are meeting at H only, right? So it has to be orthocenter. Now that is the first part. So if I want to find H, I need to prove a result which is nothing but my HF will be equal to FE for any triangle. Okay guys, so I will write down the result first. My HF is equal to FE. But how do we prove that? Let us have a look at it. So guys, can I say that AD FB, can I say ADFB is a cyclic quadrilateral? Can I say that ADFB is a cyclic quadrilateral? Why is ADFB a cyclic quadrilateral? So think of it this way. Can I think of AB as a diameter of a circle? And if I say AB is a diameter of a circle, will that circle pass through D and F? If I say AB is a diameter of a circle, will that circle pass through D and F? Yes, because we know that angle subtended in a semicircle is 90 degree. So if I say AB is diameter, this angle is 90 degree because it is altitude, and this angle is also 90 degree. So yes, ADFB is a cyclic quadrilateral. And what do I mean by a cyclic quadrilateral? All the four vertices lie on a circle. So do all the four vertices ADFB lie on a circle? Is there any circle for which ADFB will lie on the circle? Yes. That's how I proved it. And what is that circle? That circle will have AB as diameter and pass through D and F. because of the property angle subtended by a diameter at the circumference will be 90. Okay, this is a very important result because using this we will be proving what I wrote here. Okay, I hope all of you got it. If you have queries about this result, let me know, I will help you out. Now I am going to move to the second part of the proof. What is the second part of the proof? So guys, if you look at this, if you look at this chord, let's say AD, can I look at AD? So guys, if you look at AD, can I say this angle is equal to this angle? Because look at AD guys, AD is a chord of the new circle. AD is a chord of the new circle. So if I say chord, chord will subtend equal angles at the circumference. So since AD is subtending equal angle at the circumference, can I say this angle is equal to this angle? Because both these points are on the circumference of the previous circle. Now coming to the next chord, which is CE. Can I say CE will subtend equal angles over here and here? Because CE is a chord which meets the circumference at A and B. You can see that CE meeting the circle at B, CE meeting the circle at A. So can I say both these angles are equal? Everyone clear with that? Brilliant. Now coming to DF. I'm sure all of you are able to see. So guys, can you see that DF is also a chord for this circle, let's say C2, this is my C1, this is my C2. So can I say DF, look at the point D, look at the point F. The line joining DF, will it be a chord for C2? If DF is a chord for C2, can I say DAF will be equal to DBF? So this will also be equal to this. So this is two lines. So these two are equal. But previously we saw this and this are equal. Now we saw this and this being equal. So can I say these two are equal? That's it, done. Because yes, this side is common, BF is common, and this angle is common, 90 degree is common. So according to ASA congruency conditions, these two triangles are congruent. So corresponding parts of congruent triangles are equal, and therefore this is equal to this. Good. So guys, any doubt here? I know there's a lot of diagram going on. I should have better drawn it and come, but I hope all of you have got the glimpse of it. You can take this as a standard result, guys. So let me state the standard result. Please listen to this very carefully. I will probably draw it down for you. So if you have a random triangle, if you have any random triangle and a circumcircle, okay, random triangle ABC, and you have a circumcircle, if you drop a perpendicular and extend the perpendicular to meet the circumcircle, then reflection of orthocenter about this side will be this point. Did you guys get it? So if you have a random triangle and draw a circumcircle for that, if you drop a perpendicular from A onto BC and produce it to meet the circle at E, then E is nothing but the reflection of orthocenter H about the line BC. Orthocenter reflection about the line BC. That will be my point E, which is exactly I proved here. Okay. So guys, let me tell you the proof again. First thing is I need to prove that ADFB is a cyclic quadrilateral. Cyclic quadrilateral means all the vertices are going to lie on my circle. Okay. So ADFB, why will they lie on a circle? Because if I have a circle with AB as diameter, then that circle must pass through D and F, because AB subtends a right angle at D, AB subtends a right angle at F. So because it subtends a right angle at D and F, I can relate it to the property angle subtended by diameter at the circumference is always 90 degree for a circle. Is that clear? So for that reason, they form a cyclic quadrilateral, which is the first part of my proof. Now if I want to move to the second part, what do? I look at the properties of circles. So first, I look at CE. So if you look at CE will subtend equal angles at A and B, because CE is a chord of the first circle C1. So CE will have equal angle here and here, because that is the angle subtended by CE at the circumference. Now look at DF. Is DF a chord? Sir, where is DF? DF is inside. How can you say DF is a chord? Guys, I am talking about circle C2. So for C2, DF is a chord. So if DF is a chord for C2, then DF will subtend equal angle at A and B, because it's a chord. It is subtending angle at the circumference A. Now look at this B. So this angle will be equal to this angle. Got it? But just now we proved this is equal to this. So this now is equal to this. So can I say these two are also equal? Yes. Therefore by ASA, this angle side 90 degree. By ASA congruency condition, these two triangles are congruent. Okay? And therefore corresponding parts of congruent triangles are equal, and hence HF will be equal to FE. Okay guys? So let me erase it. That's it. We got the result. Using that I can find out the answer. Okay? So what did I say? I got the result as F is midpoint of orthocenter and E. So orthocenter is what? Just now we got, right? Previous question we got this result. Orthocenter is Z1 plus Z2 plus Z3. If you guys remember. Now E is going to be what? E we got in the second question. Z2 Z3 by Z1. So what will be my F? My F is equal to Z1 plus Z2 plus Z3 minus Z2 Z3 by Z1 divided by 2. That will be my answer. So what will that give me? That will give me F is equal to Z1 square plus Z1 into Z2 plus Z3 minus Z2 Z3 by 2 Z1. And which option is that? Can you guys have a look and tell me which is the right one? Obviously not 1, not A, not B, not D as well. Why not D? Because 2 is not there. Here 2 is there, so it will be option C. Okay? That is how you solve it. Very good comprehension. I hope all of you guys learned something interesting from this. So let us move to the next part. Okay guys, perfect. So please take this down, pause the video, because I'm going to erase it and move to the next question. So let's see what else is in store for us. Now, the second question that I have for you today is over here, which says, in the complex plane, A and B are 2 points which are Z1, 5 minus 2i, Z2, 1 plus I. If we have PZ moving such that mod of Z minus Z1 is twice of mod of Z minus Z2, then what is the maximum area of my triangle PAB? Simple question. So guys, there are 2 ways to do it, not very difficult. So I will tell you both the ways and I will solve it using one way. The first method is, before we get into the method, I will just explain the question. So here Z is the moving point. Okay. So Z is actually moving in such a way, my distance of Z from Z1 will be twice the distance of Z from Z2. That is what is given here. So it is similar to a locus question. Got it? So here what we can do is write Z as x plus iy. So if I write my Z as x plus iy, I will get an equation in terms of x and y, and that will be the locus. So that is one way of solving it. But now I would like to solve it in a different way. And what is that? Let us have a look. Okay, I hope all of you got the first method. The first method is using Z equal to x plus iy. you solve this, open it, you will get a circle equation. Basically the answer is a circle. Okay. So the locus of this question is basically a circle. You will get it once you solve it by substituting z is equal to x plus iy. Because z is a moving point which I don't know, right? So I can substitute z to be x plus iy. I'm sure most of you will be easily understanding this method. Because whenever we face a tough question in complex numbers, our first approach will be to substitute z as x plus iy, right? So that is the first method. Quite easy, you will still get the same answer. Nothing wrong in that. Now I will teach you the second method, which is quite interesting. So guys, whenever you have a question like this, mod of z minus z1 divided by mod of z minus z2 equal to some constant, then this always forms a Apollonius circle. Okay, so this is always going to form a circle as a locus, and that circle is called as Apollonius circle because of the form. So whenever you have z minus z1 mod divided by mod of z minus z2 equal to some constant, that forms an Apollonius circle. So I will tell you what happens over here. So this will form a circle, and please don't think z1 and z2 lie on the circle. Surprisingly, they will be outside. So why does it form a circle? Let us have a look at it. Okay, so here let me say this is my point P of z. So what do they say? Distance from z1 is twice the distance from z. So this is how the point will keep moving and it will trace a circle, and that you can observe by solving this using the way which I told you earlier. Now if you know this concept of Apollonius circle, this question is very easily solvable very quickly. And how is that? So Apollonius circle, the diameter can be obtained very easily. How can I obtain the diameter? So guys, I know the point P is moving in such a way that the distance of it from Z1 is twice the distance of it from Z2. Okay. So now, can I say when the point is here, okay, can I say when the point is here, it will be one end of the diameter, and when the point is here, can I say it will be the other end of the diameter? But now, how will I find out this point P1? So P1 can be found out easily using section formula. How do I use section formula here? So P1 is a point which divides Z1 and Z2 in the ratio 2:1 internally. So can I find out the point P1? So the point P1 is nothing but internally dividing Z1 Z2 in 2:1 ratio. So now I will move back to coordinate geometry because that is easier to solve. So Z1 is what? Z1 is nothing but 5, -2, and Z2 is what? 1, 1. So P1 is a point which divides Z1 Z2 internally in the ratio 2:1. And what is P2? Can anyone tell? P2 is a point which divides Z1 Z2 externally in the ratio 2:1. So can I get P1? Can I get P2? Then the question is done, right? Okay. So let us get P1 and P2 and finish it off. So P1 is nothing but 2 into 1 plus 1 into 5 divided by 2 plus 1, comma 2 into 1 plus 1 into -2, which will be 0 by 3. And what is P2? P2 is external division. External division in the ratio 2:1. So it is going to be 2 into 1 minus 1 into 5. So it will be -3 by 2 minus 1, which will be 1, comma 2 into 1 minus 1 into -2, which will be 2 plus 2, which will be 4 divided by 1. So these are the two end points of my diameter. So guys, please go through it. Firstly, whenever you get a question in this form, it is called as an Apollonius circle, which will be like this. The point P will be moving on a circle, and Z1 and Z2 are internally divided by P in the ratio 2:1 and externally divided by P in the ratio 2:1. That will be the two end points of my diameter. Okay, so let us say what is the diameter? P1 is 7 by 3 comma 0 and P2 is minus 3 comma 4. So I got P1, P2. I want to find out what is the diameter. So diameter is what? Distance between them, right? So let me erase this. Let me erase all of this. Okay, so distance between P1 and P2 is what? I will use distance formula. Square root of 7 by 3 minus 3 is nothing but 16 by 3 whole square plus 4 square, which will be 256 by 9 plus 16 under root, which will be 400 by 9, which will be 20 by 3. So what is the diameter? The diameter is 20 by 3. So guys, when do you think the area of triangle PAB will be maximum? So we want to maximize the area of my triangle. So here PAB is nothing but this triangle. Is this maximum now? So here what is happening? My base is fixed. My base is fixed because AB is fixed. So it can be maximum when P comes here. Is it not? So the area of triangle will be maximum when my P is over here. That's it, done. Okay, so what will be the maximum height? The maximum height is radius. We know diameter, which is 20 by 3. I know my diameter, which is 20 by 3. So what is the radius? Radius is equal to half of diameter, which is 10 by 3. So the answer is area maximum is equal to half base, which is AB, into height, which is R. Because the maximum height is equal to the radius, because it cannot go more than that. Got it? So that will be the answer. So the maximum area will be looking like this. So this is the triangle when the area is maximum. So what is AB, guys? AB distance you can find out. It is going to be 4 square plus 3 square under root, which will be 5. How did I get that? Distance formula. 5 minus 1 the whole square, 4 square. 2 minus 2 minus 1 the whole square, 3 square, which is equal to 5. So answer is going to be equal to half into 5 into 10 by 3. So it is going to be 25 by 3. And do I have an option which says 25 by 3? Yes, we do have an option, which is option C. Is that clear to everyone? Guys, is everyone clear with this concept? So there are two ways to solve this. This is easier when you get used to this method. If this is too complicated, you can stick to the first method wherein you substitute x plus iy for z. Okay, you will still end up with the same circle equation. You will end up with the same circle equation and then you can solve it. Okay guys, perfect. I hope all of you got it. With that, let us move on to the next question, and the answer for this is option C. Good. Yep. The next question for all of you is right over here, which is complex numbers A, B and C are zeros of this polynomial. I hope all of you can see the question. Read it once and then I will explain it to you. Okay. So here you have complex numbers A, B and C are given to be zeros of the polynomial P of Z equal to Z cube plus QZ plus R, where Q and R belong to real numbers. Guys, that is an important takeaway from here. What is that? So whenever you have a polynomial equation with real coefficients, then the roots will occur in pairs. If there are imaginary roots, they will occur in pairs. That is the important takeaway. So here you have a cubic equation. So if you have a cubic equation, how many roots can you have? You are going to have 3 roots. And we have real coefficients. So if you have 3 roots and real coefficients, your imaginary roots, if they occur, should occur in pairs. Okay. So guys, here you have a cubic equation, Z cube plus QZ plus R equal to 0. So if you want to find out the roots of this cubic equation, you know that the imaginary roots are going to occur in pairs. So you will be having 2 imaginary roots and 1 real root. You will be having 2 imaginary roots and 1 real root. And why do I say that? Because here Q and R belong to real numbers. It is not possible to have 3 imaginary roots. That is ruled out. Got it? But I can have 2 imaginary and 1 real because these 2 imaginary can be conjugate to each other. That is, they will occur in pairs. Is that clear? Now, can there be 3 real numbers? Sir, okay, 2 real, 1 imaginary is not possible because the imaginary roots should occur in pairs. 3 imaginary also not possible, sir, because again imaginary roots should occur in pairs. But tell me one thing, why is 3 real not possible? You never addressed that. Let me tell you why 3 real is not possible. That is because we didn't complete reading the question. A, B, C are the roots, right? Now, A, B, C are going to form a right angle triangle in the complex plane. So, if you have an argand plane and you form a right angle triangle with the 3 roots, can they lie on a straight line? Obviously not, because if they lie on a straight line, you will never have a triangle, guys. So if you say, sir, 3 roots must be real, sir, that is what I feel it should be like. So if you say 3 roots are real, you are indirectly saying that all the 3 roots lie on real axis. So if all the 3 lie on real axis, how will you form a right angle triangle? Okay, so for that reason, 3 real roots is also excluded. The only possibility is 2 imaginary and 1 real. And how will the 2 imaginary look like? Let us have a look. If I say one of the roots is x plus iy, the other root is x minus iy. And guys, the beauty of this question is I can get the real root also. It is minus 2x. Can anyone tell me why? The real root is minus 2x because what is the sum of roots? Sum of roots is coefficient of z square minus coefficient of z square divided by coefficient of z cube. So sum of roots is what? 0. So if I add all the 3, I should get 0. So if I add all the 3, am I getting 0? Yes. So the real root is minus 2x. That's it, over. Now let us use it in the condition given. What is given to me? Modulus of a square plus modulus of b square plus modulus of c square is 250. What is modulus of a square? Modulus of a square is 4x square. Modulus of b square is what? X square plus y square. Modulus of c square is also x square plus y square. That is equal to 250. So what do I have from that? I have 6x square plus 2y square is equal to 250. So that leaves me with 3x square plus y square is equal to 125. That's it. That is the first relation which I get. Okay guys, so now after I get this relation, I need to look at the diagram to comprehend this even more. Okay, so let me erase this. I hope this part is clear. Now let me draw the diagram how it looks like. So let's say this is my argand plane, this is my imaginary axis and this is my real axis. Okay, so here I have my point Z3, that is my root 3. My root 3 is real, right? This is my real root. Let's say minus 2x comma 0. So this is x. So this will be x comma y and this will be x comma minus y, because the first root is x plus iy, which will be like this. The next root is x minus iy, which will be conjugate of this, and we know that conjugates are reflective about x-axis. Got it? So if you want to get a conjugate of a complex number, take its reflection about the x-axis, you will obtain it. So x comma y, when I take the reflection, it will be x comma minus y. Is that clear? Now after I obtain these two, I know that they form a right angle triangle. And guys, where should the right angle come? Can the right angle come over here? Definitely not, because this is a straight line and this is at x-axis, whereas this is not. So can they form a right angle ever? No. So the right angle, if at all it comes, it has to come here. Okay. So from this, what can I say? Distance between this square plus distance between this square is equal to hypotenuse. Okay. So let me write that down. So 3x square x minus 2x 3x whole square plus y square, that is this square. This distance square, I have written it over here. Now this distance square is what? Again 3x the whole square plus y square is equal to what? Hypotenuse square. What is hypotenuse? This is y, this is also y. So hypotenuse length is 2y. So 2y the whole square will be 4y square. That's it, open it. So you'll have 18x square is equal to 2y square. So 9x square is equal to y square. That's it, done. Got it? So multiply this by 3. So what do you get? 9x square plus 3y square is equal to 375. So we know that 9x square is what? Y square. So 4y square is equal to 375. And guys, we want hypotenuse square by 125. And what is hypotenuse square? Hypotenuse square is y plus y the whole square. So hypotenuse square is equal to 4y square. Is it not? So 4y square is what I want. So I want the ratio of 4y square divided by 125. And do I have that directly? I have it directly, right? 4y square is what? 375 divided by 125. That is 3. Good question. So that is how you solve it. I hope all of you liked it. So guys, this will be the last question for the day. I will probably give you one homework question which you guys can work it out and let me know in the comment, and I will reply to each and every one of you as usual. Okay guys? So please work out the homework question. Let me know what is the answer in the comment. I would love to interact with all of you. And if you have any doubts in today's question also, please leave a comment. We know we covered a lot of good questions, and at times I might have gone a bit faster because of the only reason we wanted to cover more questions. Although I would have preferred to solve few but in depth. Okay guys, so if we went fast in some question and you felt uncomfortable, do leave me a comment and I will reach out to you. Okay, good. So I will show you the homework question. Try to have a look at it and solve it whenever you're free. Okay guys, so let us move forward. So this is the homework question, again a comprehension. So I'm going to pause it right here. You can take a screenshot and have me as well in the slide. Okay, so take a screenshot right now. This is the first question and the second question is over here. And this is the second question. Okay, I will comment the answer after 1 day. Okay, I will give you 1 day's time to try out this question and get the answer. I will comment the right options after 1 day. Good. So that will be the end of our questions. I hope all of you learned something useful today, and if you need anything specific to be discussed, do let me know in the comment. We can plan it out and we will let you know what is the way forward. So guys, this is the motivational quote for the day, which says hard work beats talent when talent doesn't work hard. So keep going, solve a lot of questions, learn new things. You just have 1 more month left out guys. Give it your best, and I'm sure all of you will have a great time when you make it into IIT, because I can vouch for that. I have been there and the life at IIT is amazing. So keep that in mind, look at the bigger picture, put in your best effort and you will receive your reward. Okay? So thank you and see you all in the next one. But guys, before you leave, I would like to quote a few things. So we will be continuing our discussion in the Advanced Aspire series with algebra in the next class. And if you need anything in specific, suppose you want a specific chapter to be done, and if you want to address a specific concept, leave a comment, and if we feel a lot of you are lagging in that, then I will pick that up and address it. Okay? So let us be interactive, let us know what you want, and all the very best. Please keep working hard. Let us meet in the next time. Bye bye.